Mr. Cleon here from Cleon Maths. Today we're going to look at a bearings masterclass for National 5 Maths. Let's get straight into it. An airplane flies 170 miles from point X at a bearing of 125 degrees. It then turns and flies at a bearing of 230 degrees for 90 miles. How far is the plane from point X? What is it asking us here? Well, let's just draw point X on the page. A bearing is always measured from north, which is straight up. So if I draw a north line, and it's always measured clockwise from north. So if I mark on here 125 degrees, it means to turn round. So that's 90. 125 is roughly here. And if you were doing this for real, you would use a protractor to measure this angle. So if I draw it flying away, it's saying it flies away 170 miles. And my bearing here is 125 degrees. It then says it flies its distance and then it flies at a bearing of 230 degrees for 90 miles. So I've got a new bearing starting at this point here. So if I draw here, I need another north line to signify my new bearing. I need to turn 230 degrees. Well, that's going to be about here because I know that that's 180 and that's 270. And most of the time you're not having to draw these, so don't worry if you can't, but it's around about here. So he's going to fly off in this direction for some sort of distance. And that's my bearing going from north all the way around clockwise. So that angle in there is 230 degrees, and that distance is 90 miles. Great. So we're now at this position, and it says how far is the plane from point X? So I can then just complete this triangle. There's my starting point, there's my end point. The distance is the shortest distance here. That's what I want to calculate. So I've now made a triangle. Now, I've got a triangle at National 5. If you've got a triangle with angles and sides, you're using trigonometry. So bearings gets combined with trigonometry, and it's either the sine rule or the cosine rule, which is always given to you at the start of the exam paper, and we just need to work out which one's which. But before we even get there, we need to see if we've got all the angles that we can possibly get inside the triangle. So let's have a look at this question. We have got an angle outside the triangle. We need to somehow get some angles in here, or maybe in here. There's a few rules that you can use. If you've got two north lines, the two angles contained within the north lines add up to 180. It's a bit like half of a rectangle or a parallelogram, where if you drew, let's just take a rectangle for the sake of it. We know that this is 90 and that's 90. They two add up to 180. That always happens as long as these two lines are parallel, which north lines are. So they two would always add up to 180. So I can do 180 minus 125 to get an answer of 55, and I can mark that here. So that's one rule we'll use quite often. The other rule we'll use quite often is that angles around a point add up to 360. So if I start at north and go all the way around and get back to north, I'm going to make 360. Well, I've got one angle here, I've got one angle here, so I can find this missing angle by adding them up and taking away from 360. So 230 plus 55 is 285. So I could do 360 minus the 285, and that will give me an answer of 75 degrees. So I've now got an angle inside the triangle, which is really handy. So at this stage, you might look at this and think, well, I can't find any more angles. So at this point, you might go in and try and start using the sine rule or the cosine rule to find the side of the angle. Now, I'm trying to find this side here. I've already got a side and a side contained by an angle. If you've got, try to find one missing side in a triangle and you've only using one angle, it is the cosine rule. If you try to find a missing side opposite an angle. So at this point, we've got one angle inside the triangle and we've got contained by two sides. So we can use the cosine rule to find the opposite side. Just a reminder for the cosine rule, if you try to find the opposite side of an angle, then you need the angle plus the other two sides that contain the angle, okay? So a reminder of the cosine rule from the start of the exam paper. It says that a squared equals b squared plus c squared. minus 2bc cos A. So you've got a couple of options. I'm going to redraw this triangle without all the bearings so we can see exactly what we've got. There's our triangle roughly as it was before. We know that that's 75 degrees. That's 170 miles. And that's 90 miles. If you prefer to keep your triangle with the same angles and sides as the formula, then all you need to remember is you label the angle that you're using A, and the opposite side, the missing side, little a. B and C are the other two, which are always the ones which are containing the angle. So B and C are kind of going over the angle there. So I'm going to call this B and this C. And if you're using angles, that would be big B and that would be big C. So I can then just substitute into my formula. So A squared equals 170 squared plus 90 squared minus 2 times 170 times 90 times the cos of 75 degrees. So we need a calculator to work this out. So 170 squared plus 90 squared is 37,000 minus, and then I'll put in my 2 times 170 times 190 times cos 75. And that gives me 7919.862. Taking the two numbers away from each other in my calculator, I get 29080.138. So I've got 29080.138. So we can work out A is equal to the square root of 29080.138. Which, if you do it in the calculator, is 170.5 miles. And we're done there. 2014, paper 2, question 10 was, in a race, boats sail around the three buoys, A, B and C in the diagram below. B is 8 kilometres on a bearing of 60 degrees. C is 11 kilometres from B. A is 13 kilometres from C. And the first part of the question is calculate the angle ABC. So they've given us a diagram in this case, so we can just get started straight away. A to B to C. It's this angle in here. So just take a little note of that. That's this one. And if we just check, if we're given three sides of a triangle, and we can always calculate an angle using the cosine rule if we already know all three sides. If we have opposite pairs, an angle on a side, and then maybe a side, and we're trying to find the missing angle, that would be the sine rule. So in this case, it's the cosine rule. So a reminder from the start of the exam paper. So cos A equals B squared plus C squared minus A squared over 2BC. Now, there's a couple of ways to think of this. When they say cos A, they mean the angle you're looking for, we're calling A. But in this case, there's a B attached to this, so don't get too confused. It is always, the angle, the one you take away, is always opposite it. So 13 is my A here. If you want to avoid confusion, you can draw yourself a little diagram, like so, and go, right, I'll call that A because that's the angle I want, and then my 13 is my little a. Then the other two sides would be B and C, so that would be B at 11 and C would be the other side, which is 8 kilometres. So we can say that the cos of our angle equals 8 squared plus 11 squared minus 13 squared over 2 times 8 times 11. And you would get a mark at that point for substituting in. And then we need to work this out. So cos A would equal, using a calculator, you would do 8 squared plus 11 squared minus 13 squared, get an answer, then divide by 2 times 8 times 11, making sure you're using brackets, and you would get 0.09. With a bunch of other numbers. So then to get an angle, we need to do the inverse cos. So the inverse cos of 0.09 equals 85 or 84.8. So 85 degrees would be a reasonable degree of accuracy. Or if you got 84.8, that'd be fine. So just to answer the question, remember they said angle ABC. I would then write, to be very clear, angle ABC equals 85 degrees. And we're done there. So now for part B says, hence find the size of a shaded angle. Well, we've already worked out that now this is 85 degrees. And it says find the size of this angle here. So we're going to use some angle rules. We know from the previous example that I did before that if you've got two north lines, the angles inside those north lines add up to 180. So I can immediately just diagram do 120 there, because 120 plus 60 is 180. And our second rule, we often use angles around a point add up to 360. So we can do a bit of work and say 120 plus 85 degrees is equal to 205 degrees. So we get 360 minus 205, which just gives us an answer of 155. Obviously, if you kept your answer as 84.8 for part A, then you would write 155.2 instead. One mark for working out what you need to take away from 360, and the final mark for calculating it, of course. 2015 Paper 2 question 13. In the diagram below, PQ&R represents the positions of Portlee, Queenstown and Rushton. And it says Portlee is 25 kilometres due south of Queenstown, which we've drawn for us. It says that Portlee is on a bearing of 72 degrees from Rushton. Well, there's a north line, so we've drawn the 72. And it says, from Queenstown, the bearing of Rushton is 128 degrees. Calculate the distance between Portlee and Rushton. We need to know what it's asking us and maybe mark up our diagram. So let's, first of all, distance between Portlee and Rushton is this distance here. So let's put a little mark on that. Let's just call that X for the now. And then it tells us one more thing. It tells us the bearing of Rushton is 128 from Queenstown. So always notice the way they say this. From Queenstown means starting at Queenstown, going north, measuring clockwise until I'm looking at Rushton is 128. So I can immediately write down 128 degrees in here. Okay. Remember, the strategy always is try to get some angles inside the triangle. Once you've got as many as you can find, use the sine rule or cosine rule. So in this case, I've got north going all the way around to here. That's a half a turn, or angles on a straight line add up to 180. So I can do 180 minus 128. That gives me 52 degrees, and I can write 52 inside this triangle here. I don't know anything about this angle, but I've got two angles in a triangle. I've got one side and a missing side, so I can use the sine rule. I can always find this angle if I need it, because angles in a triangle add up to 360. A over sine A equals B over sine B. So I'm going to need this angle. 72 plus 52 is 124. So I can do 180 minus 124, which is 56 degrees. And that can go in here. So now remember from our sine rule, if we go to the back start of the exam paper, it says that A over sine A equals B over sine B, which equals C over sine C. That is really just telling us that angle with opposite side, angle with opposite side, angle with opposite side. So I can go these pair equal these pair. So let's just write that in. 25 is the side over the sine of the angle 56 equals, let's call our side X or A or B, whatever you want. I've written X over sine 52. Opposites, opposites. So there's a mark. Where's our mark so far? We've got a mark for getting the 52 inside this triangle, and we've got a mark for working out this. You could have called this Q, of course, because it's opposite Q. Now we need to rearrange this, so using cross multiplication is the easiest thing. 25 times sine 52 equals x times sine 56. X sine 56 equals 25 sine 52. So x equals 25 sine 52 degrees divided by sine 56 degrees. You get a mark for correctly rearranging your formula to get your side. And then your final mark for calculating it. So it's just a calculator job now. 25 times sine 52, then divide by sine 56. X would equal 23.8. And the units were kilometres for your final mark there. 2017, paper 2, question 10. In the diagram below, D, E and F represent the positions of Dunbridge, Aylesford and Fairtown respectively. It tells us that Dunbridge is 15 kilometres east of Aylesford, and it's drawn it in for us. From Dunbridge, the bearing of Fairtown is 126, which is drawn not to here, all the way round, north, down to Fairtown. From Aylesford, the bearing of Fairtown is 230. From Aylesford, 230 to Fairtown. Calculate the distance between Dunbridge and Fairtown. Calculate this distance. Let's just mark that up there with an X. No other information given. So again, the strategy is the same as before. We're trying to find angles inside the triangle, so we can use the sine rule or the cosine rule. Let's just start on this bit here. You've got north and east. That's clearly a right angle, so I can write 90 degrees. And then angles round a point add up to 360. So I can do 230 plus 90, which is 320, giving me 360 minus 320, which is 40 degrees. I can put 40 degrees inside this triangle there. On the other side, since it goes northeast, this bit also right here is 90 degrees. So that means these two add up to 126. So doing 126 minus 90, I get 36 degrees. So I've now got a second angle inside the triangle. Once I've got two angles inside the triangle, I may as well just find the third one, because chances are I'm going to have to use it. 36 plus 40, so let's just write that. 36 plus 40 is 76 degrees. 180 minus 76, because angles in a triangle add up to 180, gives us 104 degrees. So we can write that down here. And now we can check what it's asking us. To find a missing side, we've got one other missing side. So it's the sine rule, because for the cosine rule you would need this and this to get this. You've only got one side, so it must be the sine rule. So it's x over sine 40, opposites, x over sine 40 equals, and then the other side we've got is 15, and the opposite is 104. 15 over sine 104. A nice way to do this in your exam is to maybe get a different colour and just draw a line. These go together and these go together. Obviously they would go together as well, the other two, but I can't use them because I don't need that. So marks so far. You're getting a mark for 40 and 104 degrees. If you've managed to so far just calculate your angles inside your triangle, over here you've got a mark, and then you've got a mark for writing down the correct sine rule. Now we need to rearrange it. So as per usual, we can say that x sine 104 equals 15 sine 40. So x is still 15 sine 40, but then divided by the sine of 104 degrees. And that's a mark at that point as well. And then our final mark, of course, just for working that out in a calculator, 15 times sine 40, then divided by sine 104, you get an answer of 9.936. or if you're rounding, 9.9 would be fine. And the units are still kilometres. Try not to forget your units. In National 5, there's one question where they will mark the units. They won't take marks off for forgetting the units in all questions, but there's one question you can never tell which one it's going to be, so just make sure you do your units. Okay, last one, 2018, Paper 2, Question 13. Hopefully you're getting the hang of this by now. A ferry and trawler receive a request for help from a stranded yacht. On the diagram, E, F, T, and blah. On the diagram, the points F, T, and Y show the positions of the ferry, the trawler, and the yacht. Ferry, trawler, yacht. It tells us lots of information in the bullet points. Just check that it's actually already in the diagram. So it says Fy is 7.2 kilometres, it is. Ty is 5.6, it is. Ft is 10.3, it is. And it says that F is on a bearing of 240 degrees from T. 240 degrees from T to F. Good. It says calculate the bearing of the yacht from the trawler. A little bit of a different question this. It's asking us to calculate a bearing this time, not an angle. So the bearing of the yacht from the trawler. That means it's asking us, really, starting at the trawler, go north, turn all the way around, past here, up to here, so I'm facing the yacht. That's what it's asking me to calculate. Don't worry too much if you're not quite sure what it's asking you to calculate, just start off in the same way. Although in this case, as soon as you see three sides of a triangle, you should be thinking cosine rule to get an angle. So it's really just identifying which angle it's asking for. So once more time, calculate the bearing of the yacht from the trawler, all the way around to the yacht. So I'm going to need this angle here. So let's just note this angle here. That's the one I'm looking for here. Cos A is equal to B squared plus C squared minus A squared over 2BC. So quite often, again, you'll probably just want to mark your angle as angle A so that you can substitute properly, or I'll always remember really that the one I'm taking away is opposite the angle and the other two are the ones that are adding. But let's just mark it A, so for clarity, so if I call that A, that is little a, and then the other two is going to be B and C, our sides. So we can then say we've got 5.6 squared plus 10.3 squared minus the 7.2 squared all over 2 times 5.6 times 10.3. That's cos A. You'll get a mark at that point for substituting correctly into the cosine rule. So there's a mark right there. So for our next mark, if we can work out either that cos A is equal to, well, it's 85.61 on the top over 115.36, or leaving that as a decimal, which would be something like 0.742. That gives us our second mark. Then looking at our third mark, calculating the angle. So A is the inverse cos of 85.61 over 115.36, or the inverse cos of this. And that gives me an angle of 42.008. 088, sorry. So there's our third mark, and then our fourth mark is for calculating the bearing. So just to remind you, the bearing is 240 plus this 42. So we can do 240 plus 42 is 282 degrees for our final mark. This has been Claire Maths, and today we've been looking at a masterclass in bearings for National 5 Maths. Take care, stay safe, and goodbye.